The National Electrical Code (NEC) requires a dedicated circuit for the refrigerator. Load distribution is improved by dividing the outlets into two circuits, reducing the risk of circuit overloads. Separate circuits for critical appliances ensures they have reliable power. Adding additional circuits increases the cost of the electrical installation. The best option depends on the specific requirements and desires of the homeowner. Consider two options for wiring the kitchen circuits. Firstly, separate circuits for critical appliances and general outlets, and secondly, divide outlets into two circuits for load distribution. In the first option, Circuit 1, a 20 amp GFCI circuit, serves the refrigerator on a dedicated circuit. Circuit 2, also 20 amp GFCI circuit, serves the dining room outlet and one kitchen counter plug. Circuit 3, another 20 amp GFCI circuit, serves 6 kitchen countertop plugs. The second option involves dividing the outlets into two circuits for load distribution. Circuit 1, a 20 amp GFCI circuit, serves 6 kitchen countertop plugs. Circuit 2, a 20 amp GFCI circuit, serves the dining room outlet, one kitchen counter plug, and 6 additional kitchen countertop plugs. Both options meet NEC code requirements and provide adequate power for the appliances and outlets. Option 1 provides greater separation and reliability, while Option 2 improves load distribution. If cost is a concern, Option 1 may be a more economical solution. Let's delve deeper into the considerations for kitchen wiring. The NEC, or National Electrical Code, is a set of standards for electrical wiring and safety. It's crucial to adhere to these codes to ensure safety and prevent electrical hazards. One key NEC requirement is that refrigerators must be on a dedicated circuit. This means that the refrigerator should have its own circuit breaker and wiring, and should not share the circuit with other appliances or outlets. This is to ensure that the refrigerator always has enough power and to prevent it from tripping the circuit breaker if other appliances are used simultaneously. Load distribution refers to how the electrical load is spread across different circuits. In a kitchen, where many appliances and outlets are used, it's important to distribute the load evenly to prevent any one circuit from being overloaded. Overloaded circuits can trip the circuit breaker, causing inconvenience and potentially damaging appliances. Dividing the outlets into two circuits, as suggested in Option 2, helps to distribute the load more evenly. This reduces the risk of overloading any one circuit and ensures that all appliances and outlets have sufficient power. Convenience is another factor to consider when wiring kitchen circuits. Having separate circuits for critical appliances, such as the refrigerator, ensures that they have a reliable power supply. This is particularly important for appliances that need to run continuously, such as refrigerators, as any interruption in power can cause them to malfunction or spoil food. Cost is always a consideration when undertaking any electrical work. Adding additional circuits increases the cost of the electrical installation as it requires more wiring, circuit breakers, and labor. However, it's important to balance the cost with the benefits of having a safe and reliable electrical system. In some cases, it may be worth spending a bit more to ensure that the kitchen wiring is done correctly and meets all safety requirements. In summary, when wiring kitchen circuits, it's important to consider the NEC code requirements, load distribution, convenience, and cost. The best option will depend on the specific needs and preferences. Both options presented here meet NEC code requirements and provide adequate power for the appliances and outlets. Option 1 provides greater separation and reliability, while Option 2 improves load distribution. If cost is a concern, Option 1 may be a more economical solution. Let's further explore the implications of each option. Option 1, with its dedicated refrigerator circuit, offers the highest level of reliability for this critical appliance. The refrigerator is isolated from any potential overloads caused by other appliances sharing the same circuit. This is particularly important in modern kitchens, where appliances like microwaves, toasters, and blenders can draw significant amounts of power. By having a dedicated circuit, the refrigerator is less likely to experience power interruptions, which can be crucial for maintaining food safety. The downside of option 1 is that it requires more wiring and a separate circuit breaker, which can increase the cost of the electrical installation. However, for homeowners who prioritize reliability and peace of mind, this extra cost may be well worth it. Option 2, on the other hand, focuses on load distribution by dividing the countertop outlets between two circuits. This approach can be beneficial in kitchens where multiple appliances are frequently used simultaneously on the countertop. By spreading the load across two circuits, the risk of tripping a breaker due to overload is reduced. Option 2 may be a more economical solution, as it requires less wiring and fewer circuit breakers compared to option 1. However, it's important to ensure that each circuit is properly sized to handle the expected load. This means calculating the total amperage draw of all the appliances that are likely to be used on each circuit at the same time and ensuring that the circuit breaker is rated appropriately. In addition to these two options, there are other considerations to keep in mind when wiring kitchen circuits. Firstly, all kitchen circuits that serve countertop outlets must be GFCI protected. GFCI stands for Ground Fault Circuit Interrupter, and these devices are designed to protect against electrical shock. GFCIs constantly monitor the current flowing through a circuit, and if they detect any leakage current, they will quickly trip the circuit breaker to prevent a potentially fatal shock. Secondly, it's important to use the correct size of wire for each circuit. The size of the wire is determined by the amperage rating of the circuit breaker. For example, a 20 amp circuit requires 12 gauge wire, while a 15 amp circuit can use 14 gauge wire. Using the wrong size of wire can create a fire hazard, as the wire may overheat and melt if it's carrying too much current. Thirdly, all electrical work should be done by a qualified electrician. Electrical work can be dangerous, and it's important to have the knowledge and experience to do it safely and correctly. A qualified electrician will be familiar with the NEC code requirements and will be able to ensure that the kitchen wiring is done properly. Let's consider some specific scenarios to illustrate the importance of proper kitchen wiring. Imagine a situation where a homeowner is using a microwave, a toaster, and a coffee maker simultaneously on a single 20 amp circuit. Each of these appliances can draw a significant amount of current, and if they are all used at the same time, they may overload the circuit and trip the breaker. This can be frustrating and inconvenient, especially if the homeowner is in a hurry to prepare breakfast. Now, imagine a different scenario where a refrigerator is sharing a circuit with several other appliances. If one of those appliances experiences a fault, it could trip the breaker and shut off power to the refrigerator. This could cause food to spoil, which can be costly and potentially dangerous. These scenarios highlight the importance of proper load distribution and dedicated circuits for critical appliances. By carefully planning the kitchen wiring and following the NEC code requirements, it's possible to create a safe and reliable electrical system that meets the needs of the homeowner. When deciding between option 1 and option 2, it's helpful to consider the homeowner's lifestyle and how they typically use their kitchen. If the homeowner frequently uses multiple appliances on the countertop at the same time, option 2, with its emphasis on load distribution, may be the better choice. On the other hand, if the homeowner primarily uses the kitchen for basic cooking and food preparation, option 1, with its dedicated refrigerator circuit, may be sufficient. It's also important to factor in the future needs of the homeowner. Will they be adding any new appliances to the kitchen in the future? If so, it's wise to plan ahead and ensure that the electrical system is capable of handling the additional load. This may involve adding additional circuits or upgrading the existing wiring. In addition to the considerations mentioned earlier, it's also important to think about the placement of outlets in the kitchen. The NEC code requires that countertop outlets be spaced no more than 48 inches apart. This is to ensure that there are enough outlets available to meet the needs of the homeowner. It's also a good idea to install outlets in convenient locations, such as near the sink, the stove, and the refrigerator. These outlets can be used for small appliances like blenders, food processors, and electric knives. Another important aspect of kitchen wiring is grounding. Grounding is a safety feature that helps to protect against electrical shock. All kitchen circuits should be properly grounded, and all appliances should be plugged into grounded outlets. Grounding provides a path for electricity to flow back to the source in the event of a fault, which can help to prevent electrical shock. In summary, kitchen wiring is a complex topic with many factors to consider. The NEC code provides a set of standards for electrical wiring and safety, and it's crucial to adhere to these codes to ensure a safe and reliable electrical system. Load distribution, convenience, and cost are all important considerations when planning kitchen wiring. The best option will depend on the specific needs and preferences. Whether it's the selection of one of the two aforementioned options or another strategy, proper planning is crucial to meet NEC standards. Both options presented here meet NEC code requirements and provide adequate power for the appliances and outlets. Option 1 provides greater separation and reliability, while Option 2 improves load distribution.